With 7.2, we're going to talk about multiplying. Now, multiplying is straight across when it was fractions. But here we don't want to actually multiply these polynomials together and then try to factor and cancel. What we can do instead is we can factor everything before we multiply straight across. That's the idea. So it's really, multiplying is just more factoring and canceling. And that's what it says in your notes. Hopefully you're looking at those. Okay, so here's what we have first. And we have 4 different things. Some of them factor, some of them don't. I see that these 2 factor. These 2 stay the same. So I'm going to go left to right. And I'm going to factor 6 out of that first one like it's the GCF, because it is. And then this 4p squared stays the same. And then I'm going to factor out a 9 here. I'm going to left p minus 1 after I divide by 9. Okay, so that's factoring these 2 into these 2. And what that does is it allows me to cancel these. The 6's cancel. Now notice, the 6 isn't connected with a plus or minus. That's why he's allowed to cancel. See here, you could have divided a 6 into both of these if that's really what you wanted to do. But I kind of like this system because now I see the p minus 1s. There's one up top, one down bottom, and they cancel. So all that's left straight across, there's nothing over here. It's just 4p squared on top and 9 on the bottom. Okay? That is multiplying. It's factoring, canceling, and then going straight across. They're just a lot of factoring. So here we have k squared plus 6k plus 8, and then k squared plus 10k plus 16. And then we have k squared plus 8k. And then we have k squared minus 5k minus 36. Ooh. So we have 4 different things that all factor. Lots of stuff. So I'm going to go down since there's not a lot of room over there. First one, we have, I'm going to go over here. No. 6, 8. We go, what 2 numbers multiply to give me 8 and add to give me 6? That's 4 and 2, right? So this becomes x plus 4 times x plus 2. This guy is 10 and 16. And so I have to ask, what 2 numbers multiply to give me 8, 16, and add to give me 10? That's 8 and 2. So this gets x plus 8 and x plus 2. I don't know what happened with my voice. This guy's not a diamond or X method, whatever you call it. It's only got 2 terms, so you can't do that. Here you have to use the GCF, k. And when you divide by k, you're left with k plus 8. This is, though, we can go back to the X method for this, -5 and -36. We go, what 2 numbers multiply to give me 36 and subtract to give me -5? -9, positive 4. Yep. So we get k minus 9 and k plus 4. Woo, it's a lot of factoring. Yeehaw! All right, x plus 2's cancel. X plus 8's cancel. K plus 4's cancel. I'm sorry, I was switching between k's and x's. Whatever, you know what I mean. K. So everything cancels except for these 2. So the final answer, just k on top and k minus 9 on the bottom. Yeah. That's what this is all about, man. That's why factoring is so important. For us to be able to multiply fractions that have letters in them, you gotta be able to factor. All right. This one's not so bad as the last one. You know, it's nice to like go easy, hard, you know. So these 2 will factor. These 2 don't. So let's just write 3y up here. Then down here they have a 3 in common. And I'm left with 2y plus 1 when I divide by 3. Here they have a 2 in common, the GCF. When I divide by 2, I get 2y plus 1. Ooh. And then 7. Okay? So that's factoring these 2. And then I look and I go, oh, look, 3 and 3 cancel. 2y plus 1 and 2y plus 1 cancel. And that's it. So going straight across, I get 2 times y and 7. As a fraction. Number 4. This is another one like number 2. This is a bunch of factoring problems. x squared minus 12x plus 11. I should probably just stop talking. X squared minus 15x plus 54. X squared minus 12x plus 27. And then x squared minus 23x plus 132. Good Lord. All right, so all of these factor. They're all trinomials. They're all going to use the x method. So I need some room for that. X, we got negative 12 and positive 11. So two numbers to multiply to give me 11 and add to give me negative 12 would be negative 11 and negative 1. Right? And then for this one, we got negative 15 and 54. And I go, what two numbers multiply to give me 54 and add to give me negative 15? And that is negative 9 and negative 6. Okay. Over here, I got negative 12, positive 27. I go, what two numbers multiply to give me 27 and add to give me negative 12? Negative 9 and negative 3. So this is x minus 9. This is x minus 3. There's a little times here. And then the last one here, we got negative 23 and 132. And I go, what two numbers multiply to give me 132 and add to give me negative 23? Well, this one is not so easy. But if you remember your 12 times tables or your 11 times tables, maybe you'll remember 11 times 12 is 132. And when you add them together, you get 23. So that's the answer for that. X minus 11, x minus 12. All right. Woo, that was a lot of factoring. Gosh. Cancel. Cancel. That's it. So we go straight across, and our final answer will just be x minus 1 times x minus 3 on top, and x minus 6 times x minus 12 on bottom. No! You don't have to FOIL. If you want to, you can. I just don't know why you'd want to if you don't have to. That's just me. Anyway, sometimes that's what you get. You get a bunch of stuff from the top and a bunch of stuff from the bottom, and nothing cancels, and you just write it like that. All right. Number 5. 5. So we have 7x to the 4th, and that's going to be multiplied by x squared y divided by 21 x cubed y squared. Now, this is strange. First of all, let's put this over 1. Now, nothing factors, right? We don't have any binomials, trinomials, 4-term things. So let's just multiply straight across. Remember, we multiply, we add the exponents, and then this one is 21x cubed y squared. So now this goes back to what we did a long time ago. We've kind of set this separately. Look at the numbers and go 7 over 21, that reduces to 1 over 3. X to the 6 over x to the 3rd, that's, you subtract the exponents and you get x to the 3rd. And here, 1 minus 2 would be negative 1. So that just leaves y to the negative 1 going down. And your final answer, x to the 3rd over 3y to the 1st, which you don't have to write. So sometimes it's weird, but if it doesn't factor, you just go straight across and do old school methods with dividing, right? And with, dividing. All right. Now, dividing is KFC, so remember that. And that's keep, flip, and change. So the saying this is, I'm going to write it as I go. So it's 6y minus 6 over y. And instead of divide, I'm going to change this to times. And I'm going to flip this guy to 7y squared on top and 8y minus 8 on bottom. Now, I'm sorry I didn't write the original problem, but it was divide, and this was flipped. So that's what I did. Now I can go about factoring these two bubbas. And I get 6 parentheses y minus 1 over y. And then 7y squared over 8 parentheses y minus 1. Right? GCF? GCF? So now the y minus 1's cancel, and that's it. So I go straight across, and I get 42y squared, and that's 8y. And then I do old school methods again. 42 divided by 8, that doesn't go evenly. Ooh. But 2, you can divide a 2 out of both, and that will give you 21 over 4. And that nothing does with that. And then y squared minus y is y. Okay. So KFC means flip that second one, and then keep doing the same thing you've been doing, which is factoring and canceling. All right, x squared plus 12x plus 35 over x squared plus 14x plus 49. I'm just doing this as we go. X squared plus 3x minus 28 used to be the denominator. Now it's up in the numerator. And then x squared plus 5x also moved. Okay, everything factors. Oh, goody. So, again, 12 and 35, we go, what two numbers multiply and as 7 and 5, aren't they? So x plus 7, x plus 5. And then 14 and 49, we go, what two numbers 7 and 7, isn't it? That looks like a question mark. I'm not confused. Hopefully you're not either. X plus 7, x plus 7. And if you are, you need to go back and look at factoring if that's the issue for you. This one, you got 3 and negative 28. And then you got to say, what two numbers multiply to give me 28, but subtract to give me 3? Well, let's see. That's 7 and 4, I think. 7 and negative 4 would work. They multiply right, and they subtract correctly. Larger number keeps the sign. So x plus 7 and x minus 4. Down here, don't do it. It's just GCF. You pull out an x, and you're left with x plus 5. And we're all factored up. Now let's cancel some stuff. X plus 5s, x plus 7s, x plus 7s. All right, we're left with x minus 4 in the top and x in the bottom. Do not cancel those x's. Don't be like that. Be better than that. Numero 8. Okay, we have x squared minus 12x. Wait, nope. 16x plus 64. And then 4x minus 32. Changing it to times, flipping it. 24 is up top now. And then 6x minus 48. Good Lord. Yeah, right. All right, so let's factor this one and this one and this one. 3 of them factor. This guy's going to need a little x. Next, negative 16's up here. 64 is down there. Two numbers that multiply to give me this and add to give me this was going to be negative 8 and negative 8. So x minus 8 and x minus 8. This one needs a GCF treatment. 4 goes into both. So when we divide by 4, we get x minus 8. Oh, that works out lovely. 24 stays the same. And then this one, 6 goes into both. It's a GCF, and I'm left with x minus 8. I drew my 8 weird. That's okay. So cancel, and then go straight across. 24 is the only one up there. 4 times 6 is 24. And ew! 24 divided by 24 is 1. Isn't that nuts? Sometimes we take things with letters and we divide them, and then we end up getting 1. It's wild. Wild stuff. Number 9. We got x squared minus 23x plus 132. Oh, I've seen that number pretty recently. And then 12 minus x. I'm seeing that that's out of order. Little things I'm noticing. Now, this was x plus 11 over 1. And when I flip it, it's going to be 1 over x plus 11. All right, so he's good. He's good. Well, not quite good, is he? He needs to be factored. And if you go off to the side and you go negative 23 and 132, you go, what two numbers multiply? It's 12 and 11, and they both have to be negative. So we end up getting x minus 12, x minus 11. I knew it. I knew it was out of order. So down here, because the signs are wrong, I'm going to factor out a negative 1. You remember that? Now I'll give you negative 12 plus x, and then these two will be the same. And this guy stays the way he is. All right, so because these are both minuses, but this is a plus, these will cancel, but these do not cancel. Don't do it. Just because they have the same letters and numbers doesn't mean that they do, because the signs are wrong. So if we go straight across, we have x minus 11 up top, and then we have a negative 1 and an x plus 11 in parentheses in the bottom. And that's not what they have, I'm sure. This is number 9. Yeah, okay, so what they did is they brought this negative off to the side. And so it looks like this, right? X minus 11 over x plus 11, but with a minus on the side. Okay. It's just one of those things that negative 1 can do. It can move from the denominator to the top, to the side. It has that power. Not a great superpower, but still. Number 10, x plus 9 stays the same. And I'm going to put x plus 9 over 1 because that helps me. And then this one flips, so it's 4 minus x up top now. And it's x squared minus 13x plus 36. All right, so he factors. And he's out of order. I already know what's going to happen with him. He doesn't do anything. So I'm going to leave him the way he is, x plus 9, put him in parentheses, over 1. I'm going to pull out a negative 1. I'm just going to go ahead and do it. I know I'm going to have to because it's out of order. And it's negative 4 plus x is another way of writing that. Sorry. And then this one, negative 13 and 36. I ask myself, what two numbers multiply to give me 36 and add to give me 13? It's 9 and 4. So we get x minus 9 and x minus 4. So again, x minus 4's cancel, but these don't, because one's plus and one's minus. So the negative, the x plus 9, the x minus 9. There you go. All done. Thank you for coming.